our first operation unit. Now, for this one, we're adding whole numbers, and there are places in our TEKS that it's adding, subtracting, comparing. And for this unit, we're only working on addition. So we have 6 TEKS that we're focused on. 2 of them are readiness TEKS, and 4 of them are supporting TEKS. And we have 15 days for this unit. And there's a lot of learning that happens in this unit. So first, 1.3a is one of our supporting. This ties very well to place value because we just finished in Unit 1 working with writing numbers in expanded form. And this is now saying, if I have a multiple of 10 and a 1-digit number, how do I add them together? So where in our place value unit, we were taking a number and decomposing it to say 67 is 60 plus 7. Now we're taking a number that's 60 plus 7 and asking what that total is. So it's very closely related to our place value. Then 1.3b, this is one of the ones where it mentions separating and comparing sets within 20. We are not doing that part yet. That will be our next unit. So for this unit, we are using objects and pictorial models to solve word problems. So we're not giving kids just a sheet of computation facts, and we are joining sets within 20, and the unknown gets to be in any one of the terms in the problem, and I've given you some examples there as well. Then we'll do 1.3c, where we're composing 10 with 2 or more add-ins. So it's not always going to be just 2 numbers added together to equal 10, and that's with and without concrete objects. Another supporting standard, 1.3d, this is where we're understanding our basic fact strategies. Again, just adding right now within 20, including making a 10 and decomposing a number leading to a 10. We'll talk about what that means. 1.3e, this is where we get our kids talking, where we're explaining our strategies used to solve addition only right now problems, but using spoken words, objects, pictorial models, and number sentences. And then lastly, our other readiness TEK is our generate and solve problem situations. Now notice in first grade, when you're given a number sense involving for this unit addition up to 20. And I've given you the unit progression here as well that we're going to look at. The tools that we're going to use for this unit, linking cubes, all sorts of counters, fingers, because we have a built-in set of 10, and we'll talk about that as well. Base 10 blocks, 10 frames, open and regular number lines, hundreds charts, strip diagrams, number bonds, and number sentences. So let's start breaking this down. So throughout the whole unit, we're going to be doing word problems. We're not going to just do facts over and over again. We want kids to apply it in word problems so that we have the understanding of why am I adding two things together. So we're going to use objects and models to solve addition word problems within 20, where the unknown is in all parts of the problem. And that means we could have start unknown. And let's talk about what that means. So a start unknown problem sounds like Terry had some pencils and Terry got 5 more pencils. Now Terry has 25 pencils. How many pencils did Terry start with? So that would be blank plus 5 equals 25. Change unknown. Terry had 20 pencils and Terry got some more pencils for her birthday. Now Terry has 25 pencils. How many pencils did Terry get for her birthday? That would be 20 plus blank equals 25. The change is what we don't know. And then result unknown is what we're most comfortable with. Terry got 20 pencils for her. Terry had 20 pencils. She got 5 more for her birthday. How many pencils does she have now? 20 plus 5 equals blank. The result is what's not known. Additive comparison, I've got a good example of that in your scope and sequence for you. And then part, whole, there are examples of that as well. So I want you to make sure we're seeing all different varieties of problems. A lot of times I get calls in this unit and I hear things from teachers like, but my kids are they're doing fine. They can solve every problem I put in front of them. And I say, have you done start unknown? Have you done change unknown? Or are all of your word problems result unknown? Because what happens is kids are pretty sharp and they figure out, wow, every problem that my teacher's giving me is addition. So I can just use these two numbers, add them together, and get the right answer. And you think, oh, they get it. But when you change the problem up and you give them start unknown or change unknown, then you're really able to assess their understanding of what is actually going on in the problem. So that's why we want to vary the kind of word problems that we're giving to them. So we also, throughout the whole unit, expect students to explain their strategies. This is the exact same thing you expect in science. Explain what's happening in this problem. It's the exact same thing you do when you're in ELA and you're reading, and in social studies and you're reading. Tell me what's happening in this story. Talk about the story components. What's the start? What happened at the beginning? What happened in the middle, or what changed? How did the story end, or what was the result? Those are all connected. It's all the same skill where we're figuring out what is going on in a story, and then we're explaining that. So we want kids to use our explanations using spoken words, acting it out, writing about it, and then equations. So models, equations, drawings, acting it out with a friend, using manipulatives to act out what's happening in the story, and explaining with our spoken words what's going on. So those are things that we do from the very beginning of the unit all the way through. We embed problem solving and word problems all the way through to the very end of this unit. So we're going to look at one thing that I need you to really lay the good foundation for us. We have to be sure that we are not teaching kids to rely on keywords when they're trying to figure out what to do in a word problem. Now, I have a really good article that's linked for you right here. If you click on this box, Say No to Keywords and Cubes. I've shared it in our newsletter before, but if you didn't read it in the past, or if you're new, then this is a great article that will help you understand. And so I want us to look at these word problems real quick to understand why we say no to keywords. So this says Christy has 15 chocolate chip cookies. She has 13 more than Terry. How many chocolate chip cookies does Terry have? Now, typically, when we see Christy has this much and she has 13 more than Terry, then we want to add them together. But that's not the question. How many chocolate chip cookies does Terry have is a subtraction problem, because we know how many Christy has, 15, and we know that's 13 more than mine. That means I must only have 2. So do you see that in this case, we've got to be really careful how we are approaching this problem. We approach it with pictures and building it with manipulatives so that we can figure out what the operation is. So here's another one. Christy has $25. She and Terry have $37 altogether. How much does Terry have? We tend to have kids who see the word all together and they think, oh, I'm supposed to put them all together. I should add this together. But she and Terry have $37 altogether is the total. So this would be a subtraction problem, not an addition problem. Terry has $90. She has $10 less than Christy. How much money does Christy have? A lot of kids see less than and they think they should subtract. But in this case, Terry has 90, and that 90 is 10 less than what Christy has. So I have to put those together to find out what Christy has. So this is just a good reminder that we're not going to teach keywords. We are going to teach kids to act it out, explain it, talk about it, draw pictures about it, to understand what's going on in a word problem, not look for keywords like more than, less than, altogether. We want to make sure we are really teaching kids to understand what's happening in that problem, rather than picking out certain words that we might think tell them an operation to do. So that's really, really important for us, especially before they get to second grade and problems get harder. They move to multi-step problems. So we're going to lay that really good foundation for students to have that understanding. So our first part of the learning progression in this unit is composing 10 with 2 or 3 add-ins. Now, the first thing we're going to do is compose 10 with 2 add-ins. if we were using 10 frames, then it could look like this, and we could have 3 different color counters. We would use 2 different colors when we're doing 2 add-ins, and we could use 3 different colors if we were doing 3 add-ins. So if I asked a student to add 6 plus 4, they could do 6 of one color, 4 of another color, and see if they have composed 10. So we want them to understand all the different sums of 10 there are, so that when they are moving to harder problems, then they're able to say, oh, that's a 10. I can put that 10 together. We want them to use their fingers. They have a set of 10 built in. I have to tell you guys, from teaching older grades, you might be surprised how many kids, by the time they get to 5th grade, are still counting on their fingers. And so you think, oh, let's stray away from that. Well, it's developmentally appropriate when they're 6 years old to count on their fingers, because I have a built-in set of 5 here every time, right? I have kids in 5th grade that still count to see if this is 5. They're going to add 2 numbers together. They start with 1. I need them to know this is 5 every time. I don't have to count it. I know it's 5. And this is 10 every time. I don't have to count it. I know it's 10. So in 1st grade, using their fingers is okay. It's a built-in system, right? We have a base 10 system and we've got 10. So that's a built-in system. We want them to use that in 1st grade. Now we're going to progress past that as they get a little bit older, but we're going to lay that foundation in 1st grade of this is 10, a full 10 frame is 10, a domino could have 5 and 5 to be 10, all the different ways that they could get 10. We want them to build that understanding now. So concrete objects could also be linking cubes, your 2 color counters, base 10 blocks, using the units so they understand that 10 minutes. Hold on, it's telling me it needs to stop my meeting, but I want to continue it. The units, I put 10 of them together and I get a 10, right? So we want them to use that to compose 10, especially if you've got a student that's still struggling to build that understanding of a rod is 10. So we'll use those concrete objects every time. And then the other part of this TEK is without objects. So without objects, we could use equations. We might use number bonds. We could use a number line. We could use our hundreds chart. So there's all kinds of other tools that are without objects. And then I put this reminder here of a 0, because our students need to start developing the understanding of what happens when we add 0 to something. So we can understand that it's still a number and it can be added. It just doesn't change what you have. If I have 7 of something and I put 0 more with it, I still did 7 plus 0, but I have 7 still. So we're building that understanding in 1st grade as well. All right, moving on. Basic fact strategies to add to 20. So in this case, we're going to take time to teach good fact strategies. Now, a good reminder for us is that 1st grade does not require automaticity with their basic facts. That's a 2nd grade TEK. We're introducing them, and we're introducing a lot of great strategies to understand how to add numbers up to 20. But we are not expecting automaticity. So we should not be doing timed fact tests. Well, we shouldn't be doing that at any grade level, but we are not doing fact memorization. We are building strategies to understand how to add our facts. A great way to do that is through number talks. So at the beginning of the year, we do a lot of subitizing number talks. Once we've learned some of these strategies, we can start introducing those in number talks. So the make a 10 that we just talked about, all the ways to make a 10. Doubles, we want our kids to know that 3 plus 3 is 6, 4 plus 4 is 8, 2 plus 2 is 4. We want them to know their doubles. And then near doubles, such as 5 plus 6 is the same as 5 plus 5 plus 1. So 5 plus 5, I know my doubles, that's 10, plus 1 more. Or doubles minus 1. If I'm trying to figure out what's 5 plus 4, I could either do 4 plus 4 plus 1, or I could do 5 plus 5 minus 1. So a doubles plus 1 or a doubles minus 1. And then counting on, which a lot of students use, particularly as we start moving toward bigger numbers, since we are using these strategies to add to 20. We want to teach them how to count on. So the way that sounds with a kid, if I'm trying to add 9 plus 4, I'm going to start with the bigger number, and then I'm going to start counting the number after that. So 9 plus 4, I would say 10, 11, 12, 13. I would use manipulatives to do that. I would use a rec and rec. I would use a number line. I would use a hundreds chart. But I start with the bigger number and then I count on to that number. And then when we get to subtraction, the related strategy for that is counting back. Now we're looking at our addition strategies, and this would be counting on. Then we talk about fact families or related facts, or you may hear them called turnaround facts, basically understanding that math property that I can reverse add-ins and still get the same answer. So if I have 3 plus 5, that's the same as 5 plus 3. So my fact families, 5 plus 3 is 8, so 3 plus 5 is 8. Here's what I want to warn you about. I don't want kids to just have to believe you that that fact is the same, even if I mix the numbers up. I want them to explore that with manipulatives. So if I say, model for me 5 plus 3, let's build a set of 5 and a set of 3 and find out what the total is. And then let's say, I wonder what the answer to 3 plus 5 is. And let them understand that it's okay. I reversed those two numbers and now I have 3 plus 5 and I still get the same answer. We want them to discover that. So we don't want to just do it once. We don't want to just tell them. We want to do that with lots of problems so that they develop that understanding that with addition, I can rearrange the add-ins in whatever order I want to, or however I need to make it simpler and efficient for me to add them, so that I get the same total no matter what order the add-ins are in. So for this one, we are going to use Lincoln cubes, counters, fingers, 10 frames, double 10 frames because we are adding up to 20. So we would use double 10 frames. A rec and rec. This is a rec and rec. This is a small classroom size one, and you can see that it's a sum up to 20. So it's got a row of 10 and a row of 10. And within that row, you've got a 5, a 5, a 5, and a 5. So we're building some strategies there. Number lines and hundreds charts are also tools that we will use for this unit. So we could talk about using a hundreds chart for adding on. So if I go back to my problem of 9 plus 4, I'm going to point at my hundreds chart over here. If I started at 9 and I count on 4 more, 1, 2, 3, 4, I land at 13. So that I can see that my answer to 9 plus 1, 2, 3, 4 more is 13. So we want to use a hundreds chart for that as well. Number lines work the same way, and we'll look at an example with the number line in a minute. But for this particular one where we're building those basic fact strategies, let's talk about ways that we can make that really flexible for kids by pulling that into number talks and really setting them up with problems that make these fact strategies the most efficient way to solve it. So we don't want kids to always count on their fingers. We want to teach them, let's try to use some of these strategies that we have been learning. Let's try to see if we can make a 10. Let's try to see if there's a double or a near double. Let's count on if not. We don't want them to always start by counting from 1. So if I was doing 9 plus 4, I wouldn't want them to count up to 9 and then count on 4 more. I would want them to be able to start at 9 and count up. So we're working towards efficiency, and that's why these strategies are so important. We'll build those in with our number talks as we start getting a little more fluent with them, and then really encouraging the flexibility to try other strategies besides the one that's most comfortable. If I've come and done a number talk in your classroom before, you've heard me challenge kiddos after we do one. This time I want you to pick a different strategy to use. I want you to choose a different strategy, or I want you to choose which one of your friends used a strategy that you hadn't thought about using, and I want you to try to use that one. So lots of different ways you can help encourage flexibility in your kiddos. This picture is a link to a rec and rec if you needed one. So now I have to, so that way you could just see what that actually looks like. Now let me get back to where I was. All right. So that's our fact strategies up to 10. So we've talked about composing 10. and with 2 or 3 add-ins, and now basic fact strategies to add to 20. So what we do next is generate and solve word problems with sums to 20 when given a number sentence. So let's talk about this for just a second, and then I'm going to show you where I've got a really good resource for you. So in this problem, our TEK says that our kids have to generate the word problem and solve it. So that might look like, here's this equation for you. Write a word problem that would go with this equation. So again, we should be having kids see start unknown, change unknown, result unknown, additive comparison, and part whole problems. And we could expect our kids, not at the beginning, but as we've scaffolded this and as we've learned, we could expect them to use up to 3 add-ins and include 2-digit numbers because all of these TEKs in this unit are connected. So when we start learning how to do this, we want to start by giving kids some support around the equation, not just a blank equation, 7 plus 11, write a word problem. That's pretty intimidating to a 6-year-old or 7-year-old student. So we want to start by providing some support for them as they learn how to do this. So like in the example I've given you here, 7 race cars plus 11 race cars equals 18 race cars. So in this type of problem, I'm not even asking them to solve it. I'm just asking them to come up with a story that you would use this equation for. So I might say, Terry has 7 race cars, Christy has 11 race cars. How many race cars do they have all together? They have 18 race cars. So we're going to start by building the scenario for them, building the story that their word problem is going to be about race cars. As we grow, we're going to take away that support and just give them an equation. We're going to take away the answer. At the full limit of the TEK, we're going to expect them to generate the word problem just given a number sentence, so not with a scenario around it, and solve their word problem. So that's the full limit of the TEK, but this is how we scaffold it. So I want to show you where you have in your Google Drive where we have a resource for this. So remember, I'm logged in as my staff account. You have to be logged in with your student account. So your name at student.gccisd.net. When you are, then you'll go to shared drives. And I have a ton of them, so just you probably don't. That's okay. So you'll go to GCCISD Elementary Mathematics, and then you'll see files that you may have opened, and you'll see some folders here. You'll go in first grade, and as soon as you go in first grade, you're going to see right at the bottom, files, first grade, generate a word problem. And when you click on it, it's going to tell you you have to download it because it is for your Promethean board. It's an Active Inspire file, flip chart. So I'm going to download it and show you how that works. I'm going to stop sharing my Google Slides so I can start sharing as soon as that decides to open. Share. I want to share my Active Inspire right there. And you'll see that I have several word problems for you. So here's the example that I showed you a few minutes ago. And then we have, here's another one, some ice cream cones. You can see on this one, I didn't give them the solution. I said, write and solve a word problem for this number sentence. But I've still told them their problem's going to be about ice cream cones. Here I have 9 students plus 3 students, write and solve a word problem. And then I've given them just the number sentence. They have to write and solve, but I've still given them a picture. So they can, if they don't have an idea for 15 plus 4, they could write about sports, basketball, baseball, football, soccer. They can write about sports. And then here's another one for them. Not telling them they have to write about the things in this picture, but giving them an idea for if they're stuck, here's some ideas. You can write about some of the sea creatures that you see here, but this is your problem and you're going to solve it. And then we'll use, this one is also, I took away the plus sign to see if they know that this and this, we're putting them together. and then we will get to subtraction, which right now we're not doing the subtraction part. That will come in our next unit. But I wanted you to see an easy way to scaffold students' learning and to help them move from never having written a word problem of their own before to being able to write it with some support, write it as they learn without any support. So just another tool for you to use. I've seen great, I'm going to share my screen back with you. I have seen, let's see if that's the right one. Yes. Some great activities where, let's see if that'll get out of my way. Teachers have used, that doesn't want to move. It's going to any second now. There. Where teachers have used different tools online, like a random name generator or a wheel. And the way they use that is they put emojis on it. And so they would spin the wheel and it would land on pizza, and they would roll a dice and they would say 6 plus 8, and your story is going to be about pizza. So then the students would write a story about that. And you could do that with drawing cards out of a baggie as well, but just another tool to be able to do that. So the next thing that we are going to talk about is adding, I really want this to move out of the way, is adding numbers when we have a multiple of 10 and a one-digit number. So this is where we are working with the opposite of expanded form. I'm sorry, I feel a little scattered because my video is not showing right and there's a big black box in front of my slides, so it's hard for me to see. So I wanted to give you several tools to work with for this particular team. So if we were going to solve the sum of a multiple of 10 and a one-digit number, we are going to do that with tools, and we're going to do that with a number line. So it could look like place value blocks, and it should, because that ties to what we've done before with expanded form. So if I had 30 plus 5, I could expect students to build 3 10s and then 5 1s. I could use 10 frames where I fill up 3 10 frames because that's 3 10s or 30 and then 5 on another 10 frame. And you can see I did it with different colors just to separate the 10s from the 1s. We could also do number bonds. We could have an open number line where we get kids to fill in the number lines, and you can see how I modeled that across the bottom here. We can do strip diagrams for that. We can use rec and recs. We can use all sorts of tools, but we really, really want to tie this back to what we learned in our place value unit with expanded form, where we took the number 35 and we said 35 is equal to 30 plus 5.